Let's try to learn how to solve simultaneous linear equations. But before we begin that, let's try to revise what it means for a point to lie on a line. So let's take a look at a linear equation like maybe 2x plus 3y is equal to 5. So we can clearly sketch it. So let me try to sketch it. Here's a sketch. So we know that when x is equal to 0, y is equal to 5 over 3. When x is equal to 0, y is equal to 5 over 3. So let me 5 over 3 is going to be maybe this point right over here. So this is the point 5 over 3 somewhere over here. It's approximate, but that's what roughly x equal to 0, y is equal to 5 over 3. And when y is equal to 0, x is equal to 5 over 2, which is 2.5. So this would be this point, right? So the line would look something like this. So I can draw this line. Here's this line. And I can draw it. This would be roughly the line that I'm trying to draw through these points. So let's try to draw this line in somewhat of a reasonable way. Okay, so this is maybe what it looks like. Maybe not exact, but this is roughly what it looks like. Okay, so this is the line 2x plus 3y is equal to 5. So the line 2x plus 3y equal to 5 looks something like this. So for a point to lie on the line, let's pick a point. Let's say like a point like maybe a point like pick any point. Let's pick a point where x is equal to 2. So if I pick a point where x is equal to 2, so let's say x is equal to 2, then I know that this implies that y is equal to 5 minus 4 over 3, which is going to be equal to 1 over 3, right? So if I turn on the grid, you can see that when x is equal to 2, y is approximately equal to 1 over 3 from the line, right? Because you can see I'm talking exactly about, let me turn on this line, and I'm talking about this point over here, the blue point, right? The blue point would be when x is equal to 2, y is equal to 1 over 3, right? Okay, so what I want to emphasize is that when a point is on the line, then it satisfies the equation. So every point on the that satisfies the equation lies on the yellow line, and every point on the yellow line satisfies the equation 2x plus 3y is equal to 5. So pick any point on the yellow line. The x and y coordinates of a point on the yellow line will satisfy 2x plus 3y is equal to 5, and vice versa. Okay, so now let's look at another equation. So let's look at another equation, and here's our second equation, which is 3x minus y is equal to 2. So this is 3x minus y is equal to 2. And that's our other equation. That's the second equation that we have. Okay, so let's sketch it. So when x is equal to 0, y is equal to minus 2. So when x is equal to 0, y is equal to minus 2. So I can get this point right over here. This is the point. I should probably turn on the grid. So when x is equal to 0, y is equal to minus 2. And when y is equal to 0, x is equal to 2 over 3. So I have to get 2 over 3, probably maybe a point, maybe like this, somewhere over here. This would be maybe 2 over 3. So I have to draw a line. So let's draw this line. I'm going to draw a line. So here's a line. I can probably draw it. Let's try to draw this line. So here's a line that I can draw. Okay, so this is a line that I can draw. So now, please note that every point on this line, so I can pick any point. So if I pick a random point, let's say I pick this point must satisfy, if I take the x and y coordinates of this point, the green point that I've drawn, it must satisfy the equation, which is 3x minus 2y is equal to 2, right? That's what it means for a point to lie on the red line. So now you can see that there is a unique point, and that unique point that lies on the red line as well as on the yellow line, right? So you can see that there's a unique point here, right over here. So this unique point right over here, right? So this is a unique point right over here, which lies both on the yellow line and on the red line. So this is what I mean by simultaneous linear equation. So simultaneously, this point right over here simultaneously satisfies the constraint of the yellow line, and it simultaneously satisfies the constraint of the red line. So both these constraints are simultaneously satisfied, and as you can see, the point turns out to be the point 1, 1. So this is the point 1, 1, which satisfies both points. That's what I mean by solving simultaneous linear equations. So if somebody says, okay, there are two linear equations, equation 1, which is y is equal to 2x plus 3y is equal to 5, equation 2, which is 3x minus y is equal to 2. So you draw both lines, and the point of intersection is where both the equations are satisfied, and that's a unique point, and that's what you can figure out. Okay, so there are things that you can think about. So now the question is, how many points? Now this may confuse you to begin with, but the question is that right now we only have one point. There's a unique circled blue point with the red circle. That's the unique point 1, 1 that satisfies both equations. But is that true in general? I mean, can more points satisfy these two straight lines, right? So let's look at the same equation, 2x plus 3y is equal to 5. So please remember, this is 2x plus 3y is equal to 5. We drew the yellow line. I'm redrawing the yellow line on the next page. The same equation, okay? So it's 2x plus 3y is equal to 5. Now, just think about it. So think graphically first. When will you have no points of intersection? That's an important point to think about. So how can you draw a line? So I want to draw a red line, and I want to draw a red line which does not intersect the yellow line ever. Okay, so how can you do that? Well, you know that the only way the two straight lines don't intersect are when they are parallel to each other, right? That's the only way it can happen. So maybe I can draw a line which maybe looks like this, right? So maybe I can draw a line which is parallel to this line. So let's try to draw a line which is parallel to this line. So let's try to draw a line which is parallel to this line, and I can shift it down maybe towards the origin. Let me just draw it through the origin, although I can draw other lines too. So let's just draw it through the origin. So if I draw it through the origin, I know that I'll get a line which looks maybe something like this. So here's a line that I'm going to draw which is going to be parallel to this line. Here's a line which is parallel to this line, and here's a line which is parallel to this line. This will never intersect this line. The red line will never intersect the yellow line because they're parallel to each other, right? So if I draw lines which are parallel to each other, they will never intersect each other. So there will be no point of intersection, and the reason is because both lines are parallel to each other. Okay, so this line and this line are parallel to each other. So what's the equation of this line? Well, you know that there's no y-intercept. So let me rewrite this equation. This is just the equation y, which is, I'm just going to move it to the right hand side. This is just going to be equal to minus 2 over 3. So it's going to be minus 2 over 3x plus 5 over 3, right? So remember, this was the this was the y-intercept. I can set the y-intercept to 0 because you can see the red line has no y-intercept. So the equation of this line, the red line has to be y is equal to minus 2 over 3x, or in other words, I can say that 2x plus 3y is equal to 0. That's the same equation. And this is the equation of this line. So you can see if equation 1 where 2x plus 3y is equal to 5 and equation 2 where 2x plus 3y is equal to 0, no solution. They have no solution because they don't intersect, right? So that should be fairly obvious. Now, so for example, so you can have, but that's the only way that you can have no intersection. Remember, parallel lines are defined to be lines which do not have any intersection. And otherwise, two lines will always intersect. And it doesn't have to be just this line. You can have lots of other lines. So for example, I can draw a blue line. So here's a blue line that is also parallel to this line. So here's a blue line, and I can draw this line, which is maybe parallel to this line, and this will also not intersect, right? So this line will also not intersect, and you can figure out the y-intercept and do all those things for this line as well, right? So all these lines, the yellow, the blue, and the red lines are parallel to each other. There'll be no solutions. So they can be, so parallel lines means no solution graphically. Now, what can you have more than one solution? So let's think about, can you have more than one solution? That's another question that we can think about. More than one solution. Well, you know that when two lines intersect, so just think about it. If you have two lines, so let me draw two straight lines. So here's one straight line, here's another straight line. Once they intersect, so they've intersected at this point, here's the point that they have intersected at, they're not going to intersect again. That's fairly obvious. So now, that means that right now it seems like that you can only have maybe one solution. That's when you have this kind of a problem. That's one option. The second option is that two lines are parallel to each other. So you have things like maybe a yellow line, and then you have a red line which is parallel to this, and this will be a problem with no solution, right? So we have figured out that for linear equations, there are two options. But can there be more than one? Is it possible for more than one solution to exist? So can we increase 1 to 2 or to 3 or to 4? Right now it seems that we can't do it. Well, the only way, if you think about it, because once the lines intersect, then the lines start to move away, right? You can see that these lines are moving away from each other and they're never going to meet again, right? So they come together and then they move away and they never come back. So you're not going to get the second point of intersection. Well, the only option is that the two lines actually overlap. So the two lines overlap, and now you can have infinitely many solutions, right? So let's go back and check, because now the two lines actually are overlapping. So for example, how can two lines overlap? Well, the only way the two lines can overlap is that you actually algebraically write the same equation in a slightly different way. So how can we do that? So let's think about it. Maybe we can multiply this equation by 2. If I multiply this equation by 2, what do I get? I get 4x plus 6y is equal to 10. But that's the same equation. Why is it the same equation? Well, if you rewrite it, you'll find this is the equation y is equal to minus 2 over 3x plus 5 over 3. So this and this are actually the same. These two are the same equation. And if they're the same equation, they will be represented by the same line, which means that I can draw a green line right on top of this line, the yellow line, and it will be the same line, okay? So our summary really is that we have options. In general, we have one solution, and that's the generic case. So this is one solution is the most generic case. You can have no solutions if they are parallel to each other, like the blue and the red lines. And you can have infinitely many solutions. I mean, you can see that the yellow, which is sort of like right behind the red line, the yellow and the red lines overlap, so you can have infinitely many solutions. Okay?